this second part on electric circuits, we're going to learn a little bit more about resistors. So if you remember from the previous video, resistors are components in a circuit that decrease the flow of current that passes through a particular branch. So the higher the resistance in a branch is, the least current will pass through it. The harder it is for the current to pass through it. So let's write that down. And you might remember that resistors look like this squiggly line with sharp corners. That's a symbol for resistors in a circuit. So by how much does this flow of current decrease when you have a resistor in a circuit? That's given by a mathematical equation called Ohm's Law. So Ohm's Law, written O-H-M Law, is V equals I times R. This is Ohm's Law. And V is the voltage passing through, and it's given in volts. I is the current passing through, and it's given in amperes, A. And R is the amount of resistance in the resistor, and it's given in a unit called ohms, and the symbol is the Greek letter omega. So basically what this equation is telling us is that the voltage drop across a resistor is equal to the multiplication of the current that was passing through times the value of the resistance. So let's do an example to explain how to use this in solving circuits. Okay, so here I have an example of a circuit with two branches. The first branch has two resistors. We're going to call this one resistor 1 and this one resistor 2. And the second branch has one resistor, which we're going to call resistor 3. And all the values in blue are values that I gave you, that you already have. So you know that the battery has a voltage of 10 volts, which according to our rules from the previous video, that means that every branch has to have 10 volts as well. The current coming out of the battery is equal to 4.5 amperes. So we know that if it divides, it'll add up to 4.5 amperes. And we also know that the first resistor has a resistance of 3 ohms, and that the current going through the bottom branch is 2.5 amperes. So with this, we have a lot of things that we can figure out. So first, we can realize that with the fifth rule of voltage, this branch is going to have 10 volts, and this branch is going to have 10 volts. Now, with the rule of breaking up of currents, we know that if this current is 4.5 going in and it divides and 2.5 go down, then 2 have to go through this first branch. So here we have 2 amps. And now we can start using Ohm's law to figure out everything else. So the first thing we want to know is the resistance of, for example, R3. So to find the resistance of R3, we use this equation, and if V equals IR, we can solve for R by dividing V over I. So the resistance R3 is the voltage in the third one, which is 10, over the current in the third one, which is 2.5. So R3 is going to be equal to a voltage of 10 over a current of 2.5, which is 4. So R3 is 4 omega. That's our first value. So this is 4. So now we want to figure out R2. But in order to calculate R2, we need the voltage drop there. The total voltage drop is 10 in the whole thing, but part of it will be in this resistor and part of it will be in the second resistor. So first we need to figure out the voltage drop in this resistor, so that then we can know the voltage drop in this resistor and use Ohm's law. So first let's use Ohm's law for this one. So we want to figure out V in resistor 1, so let's call it V1. And that's going to be the current 1 times the resistance 1. So V1, what we're going to find is going to be equal to I1, which was 2, times R1, which is 3. So the voltage one is 6 volts. That's another answer that we can have. So if this is 6 and the total has to be 10, this one over here has to be 4. So voltage 2 has to be 4. And now that we have voltage 2, we can then use the Ohm's law again to calculate the second resistance. So voltage 2 is 4. The current 2 is the same current 1 because it's in the same branch, so it's going to be 2. And we need to solve for the resistance. So the resistance is going to be 4 divided by 2, which is 2 ohms. So this is the value of the second resistance. And that's it. That's how we were able to calculate all the resistances and all the voltages and all the currents in this circuit using both Ohm's law and the 4 rules that circuits follow. So now I'm going to do a second example just to make sure this is clear. If you feel like this is easy for you, you can skip ahead this example to the following topic. Okay, so this second example might look a little bit more confusing, and maybe it is, but it's going to take the same steps and the same equation to solve. So let's start. So first, we have 3 amperes of current going out of the battery. The battery is 12 volts, and we have 3 resistors. Resistor 1, we don't know the value of. Resistor 2, we don't know the value of. And resistor 3 is 2 ohms. And we have that the current divides here. 3 come in, 1 goes to the right here, and the rest goes down. So the first thing we can say is that here, the current has to be 2, because 2 plus 1 equals 3. So this is 2 amps. Now, what else can we say? We know that the current that leaves the battery is equal to the current that comes into the battery. So if this was 3, this at the other side also has to be 3 amperes. And the other thing that we know is that in every branch, the total sum of the voltages has to be 12. So there's basically just one big branch that has a voltage of 12, but we're going to have to see how it divides between these 2 branches, because this part has a voltage that we don't know, and this other part has another voltage that we don't know. So to figure out this voltage, we can use Ohm's law because we do have the current, which is 3, and the resistance, which is 2. So this voltage, which we can call voltage 3, is equal to the current 3 times the resistance 3, which is, in this case, 3 amperes times 2 ohms, which is 6 volts. So we figured out first that this over here is 6 volts. If the sum has to be 12, that means that the voltage across this whole thing also has to be 6 volts, so that it adds up. 6 plus 6 has to give us 12. So this is 6 volts over here. And now with those 6 volts, we can figure out the first resistance, because we have the 6 volts, which have to be 6 here and 6 here, because each branch has the same thing, remember. So the resistance 1, we can calculate it with the equation number 1. So V1 equals I1 times R1. V1 is 6 volts. I1 in this case is 1 ampere times R1. So R1 will be equal to 6 over 1, which is 6 ohms. 6 ohms. So here R1, we figured out, is 6. And we can do the same thing with R2, but with the equation for 2. So V2 equals I2 times R2. V2 is also 6 volts. And I2, in this case, is 2 amperes because it's what was left from the 3. So this is 2 times R2. So R2 will be equal to 6 over 2, which is equal to 3 ohms. 3 ohms. So this resistor over here is 3 ohms. So that's it. We figured out all of the resistances, all of the voltages, and all of the currents of this harder circuit by using our 5 rules of circuits and our Ohm's law. So now let's move on to the last part, which is resistor networks. So as you could tell in the previous example, sometimes you have many resistors and sometimes they're in parallel and sometimes they're in series, and it could be very useful to be able to add up all the resistors to a single value and then use that in Ohm's law instead of having to use Ohm's law 3 or 4 times like we did in the previous examples. So actually there is a way of adding resistors, and it's what's called resistor networks. So we can add resistors in series and add resistors in parallel. So first let's talk about adding resistors in series. And this one is very easy. If we have 3 resistors in series, for example, resistor 1, resistor 2, and resistor 3, in our circuit, we could change this to an equivalent resistance or a total resistance. We call it R tot, which is the same as R1 plus R2 plus R3. So basically, an example, if we have a circuit and it has, let's say, a resistance of 4 omega, a resistance of 2 omega, and a resistance of 1 omega, this is the same thing as a circuit with only one resistance, where the value of the total resistance is equal to 4 plus 2 plus 1, which is 7 omega. So these two circuits are exactly the same. So you can use this a lot to simplify circuits when you have to figure out the values. Just convert them into one single resistance that is the sum of all of the resistance. If you have more, R5, R4, R5, R6, you just add them all together, and that's the total resistance for resistors in series. Resistors in parallel are a little bit more complicated. Let's do that one. So if we have, like in this example, 3 resistors in parallel in 3 different branches, we could add them by adding their inverses. So 1 over the total resistance is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3. So if they're in parallel, you can't add them as if they were in series. You have to add their inverses. If you have more, you can just keep adding them here. 1 over R4, 1 over R5, 1 over R6. And an example, suppose you have this resistors these 3 resistors. One is 12, one is 8, and the other one is 8. So to figure out the total resistance, you add their inverses. 1 over 12 plus 1 over 8 plus 1 over 8. If you do this, you're going to get 1 over 3. That's the answer to this addition. You can do it in your calculator or in your heads. So the total R is going to be 3, because this is equal to 1 over total R, right? So 1 over 3 is equal to 1 over total R, so total R is 3.